literal is a constant value that appears directly in the program. For example, 34, 1 million, 5.0, and etc. It means that literals are values of our variables. Integer literals can be assigned to an integer variable as long as it can fit into the variable. If it's too large, then only that part which can fit will be written into our integer literals. The same for other types also. Where can we find the information about it? Here, if you remember, we have here information about the size of our variables. For example, for byte, we can store numbers from 100 minus 128 till 127. It means that if you will try to store 500 instead of 1 byte, you will not be able to save it there, and only that information that can be fitted, for example 50, only it will be saved. The same for integers, long, floats, and doubles. All these storage size you can find in the presentation. Now let us come to there where we have stopped. An integer literal assumed to be of the integer type, whose value is between this number and this number, means that if you will try to try to write some number that's bigger than this, greater than this one, then you will not be able to enter all of the digits. To denote an integer literal of a long type appended with the letter L is preferred because lowercase l can easily be confused with 1. It means that if your number will be longer than this one, you just write your number at the end of this number you were adding the letter L. Or, for example, for floating point literals means that floating point literals are written with a decimal point. By default, floating point float numbers, they're assumed as doubles, but after floating number, if for example for doubles you are writing here, displaying here 16 digits, for float numbers you are showing only 7 digits. That is why for floats you are taking only 32 bits, or it means only 4 bytes if you are writing for one float. If you take size for one float, for doubles you take 8 bytes. This is important when you are trying to use some kind of variables that can be big, and that can not fit into your variable type memory size. Scientific notation. Floating point literals can also be specified in scientific notation. For example, if you see that this number comes with +2 or E2, it's equivalent to this number. It means that if you see this two numbers after E, it means that you are changing this floating point into right side for 2. Or if you see the same thing but with minus, you are changing this floating point into the left for 2. E represents an exponent, and it can be either in lowercase or in uppercase. If you are trying to use some kind of arithmetic expression, for example, in this way, we are translating it into one line arithmetic expression. Instead of exponent, this one, we are using this division sign. Instead of this what multiplication that is between 4 and x, we are using this multiplying sign. How to evaluate an expression? Evaluating expression comes the same as in the arithmetics. First of all, we are solving the part which is in the parentheses. After, we are solving the multiplication and division, and after it, we are solving addition and subtraction. This is the way we are solving the arithmetic. This is expressions and the sign arithmetic signs in expressions. For example, here we have some kind of expression. It is about converting Fahrenheit, Celsius uh, into Fahrenheit, or no, it's changing Fahrenheit into Celsius. For that, we have this kind of formula, and to find it, you are changing it in this way in our code, and you will see the answer in your code.